In this video, we are going to get do a regression analysis on our data. So we will get a regression line that's fitted to the scatter plot, and we also get regression coefficients to get the regression equation. And then we'll use the regression equation to get the predicted income levels and also the residuals. So first we'll use the graph here to fit a line through the scatter plot. So to fit a regression line, we can use add the chart elements. So you go to trend line and then click on this. So I think you need to go to the more options. So by the linear by default it will be unchecked, and I want to also add a regression equation on the chart. So you see that we fit a regression line through the data points, and also we have a regression equation. This is our regression equation. So they have the two regression coefficients. So there's the intercept and the regression slope. We can also calculate the regression on the intercept and also regression slope here. So using the Excel function. So the regression intercept is the function is just the intercept. So we'll regress our y on our x. So put the y first, of y variables, and then comma, and then the x variables. So we'll get the intercept. Let me just reduce the variables here. Which is actually similar to what we have here from add the data elements. That's the same thing, yeah. And we also can get the slope. And to get the regression slope using the formula is just the type of slope. And then add the y variables, the y data, and then the x variable data. And so this is the regression slope. Again, I'm going to reduce the decimals. So maybe I need to keep that. Let's just do 2 digits. And so here. And that will be the same as the regression equation here. So since we get the our regression equation, and we can use the regression equation to get the predicted incomes. So these are our observed monthly income. So to do that, I'm going to have here, I'm going to use the y prime to meaning this is a predicted monthly income. And so it's a y prime. And so what I'm going to do here is, so for each of the years of education, I'm going to get what's the predicted income level. So basically that will be the y predicted score will be those on the line. So for the first observations, 6 years for education. And so the observed is $1,000 and predicted is actually below that. So we can calculate use the regression equation, regression coefficients here. So to do this, yeah, so we type equal, and we will use the equation here. So I'm going to use the intercept first, so which is here, and be 17 here. I'm going to plus my slope, which is here. And then because I want to the numbers is the cell, fix the cell. I'm going to put a $sign on each of the cell, the reference here. So so that means that each time I'm just going to, if I'm go down the rows, I just want to make sure that this is in the cell. That's the value we use. And so I have this regression slope, and then the next is we're going to time the x values. And so I'm going to enter. So this is the predicted value for the first person now who with 6 years of education. You would expect that section you do not know much. And then scroll down, yes, and then fill down the information. Those are the predicted numbers. I'm going to reduce the and I'm going to put a $sign. So we can see that the predicted score for a person with 6 years of education is actually negative, which is also here the line shown up. That's here. For the second observation, 80 years of education, the predicted the observed monthly income is $1,500. Predicted is $1,130. Yeah, so it's close. Yeah, so here. And then you can see that there's differences between the observed score and the predicted score. So the difference we call between the observed score and the predicted score, those are the prediction error. So you merely use E to represent error. And then it's error between it's Y and Y prime. And we also call this residuals. Basically, it's just error. Yeah. And so so for the prediction error, just you do the observed score minus the predicted score. So that tells you the amount of error. And so these we can use this to quantify how much error we have. So the regression line, supposed to what we fit in the line, that's to minimize the amount of error using the regression equation. So this video shows how we fit a line through the scatterplot and then get the regression equation from the graph, or you can use the functions. And once we have a regression equation, we can use the regression equation to compute the predicted score and the prediction errors. Thank you for watching it.